Okay, so in this video we're going to be talking about some quadrilaterals that are not parallelograms. Alright, so all the things we talked about before were parallelograms. Now we're going to look at a few shapes, specifically the kite and the trapezoid and a couple special trapezoids that are not parallelograms, which means that they don't have two sets of sides that are parallel. In fact, the kite doesn't have any parallel sides at all. The kite is special because it has two sets of congruent sides. It has one set of congruent angles. All right. What it also has is some interesting aspects of its diagonals. This diagonal is a line that bisects the kite into two congruent triangles, right? You cut it in half, you get two congruent triangles, all right? But we're not going to focus on that right now too much. What I want to show you is the diagonals. This diagonal that runs a long way, that cuts them into two triangles, also bisects the other diagonal at a right angle, all right? It also bisects the angles that it intersects. So, diagonal that goes long bisects the other diagonal, bisects the two angles. So be able to recognize that. The trapezoid, right? The trapezoid has one set of parallel sides, right? One set of parallel sides, which means that these two angles add together to give you 180 degrees. And these two angles also add together to give you 180, but they are not the same. They don't have to be the same, right? If they were the same, then there would be an isosceles trapezoid, right? An isosceles trapezoid has congruent base angles and congruent sides. So it's kind of like an imaginary isosceles triangle that's just had the top cut off, right? So that's when you think of an isosceles trapezoid. Now, going back to the regular trapezoid, there's nothing special about the diagonals of this trapezoid. Nothing about it. It doesn't bisect, it doesn't cut proportionately. We don't know anything about the diagonals of a trapezoid. But if it's an isosceles trapezoid, then the diagonals will be congruent to each other. But it will not bisect, right? As you can see, the top portion of this is equal to the bottom portion, and the top portion is equal to the bottom portion over here. But they're not congruent to each other, right? This is congruent to here, and this is congruent to here. So when you put them together, you get the same length. All right? So let's look at one more type of trapezoid, which is called the right trapezoid. The right trapezoid has a 90-degree angle, which means this is also a 90-degree angle. And what happens with the right trapezoid is that the diagonals create right triangles, right? You have a right triangle here, and you would have a right triangle here. So a squared plus b squared will equal c squared. And a squared plus d squared will equal e squared. So you can do a little bit of right triangle trigonometry, a little bit of Pythagorean theorem with right trapezoids. All right? And of course, if you had a right trapezoid that was isosceles, you would have a rectangle. All right? And we'll get to that when we start comparing the special quadrilaterals to the special parallelograms. Okay, so those are the properties that you need to know about these three special quadrilaterals. All right, so on the back here, I want you to fill out these properties. So if it contains this quality, you should put a check in it. So we'll look at two pairs of parallel sides. Well, a parallelogram has two pairs of parallel sides. A rhombus has two pairs of parallel sides. A rectangle has two pairs of parallel sides. And a square has two pairs of parallel sides. But a kite does not, a trapezoid does not, and a isosceles trapezoid does not. Exactly one pair of parallel sides, that would be a trapezoid, and an isosceles trapezoid. Two pairs of opposite sides that are congruent. Well, that would be true for the parallelogram, the rhombus, the rectangle, and the square. All right, so go through here, fill this out, and when you're done, we'll check it. We'll talk about it when we're in class. The next thing I want to take a look at is this Venn diagram and start comparing these different quadrilaterals. Okay, so some properties, so all of these shapes are quadrilaterals, meaning that they have four sides, right? Every quadrilateral has four sides. Every quadrilateral has the sum of their interior angles equal to 360 degrees, right? Every quadrilateral will always add up to 360 degrees when you add up the interior angles, right? So what makes a parallelogram special from other quadrilaterals is that the opposite sides are parallel. The opposite sides are congruent. Opposite angles are congruent. Consecutive. Interior angles are supplementary. And its diagonals bisect. All right, those are the properties of parallelograms that make them special. What makes a rhombus special is that all sides are congruent. Its diagonals are perpendicular. The diagonals bisect the angles, right? So a rhombus, all the sides are equal, its diagonals are perpendicular, and the diagonals will bisect the angles. All right, so what makes a rectangle special is that its sides are perpendicular. Okay, rectangle, all the sides are perpendicular. In addition, the diagonals let me just try to rewrite that again. The diagonals are congruent to each other. And as we saw before, the diagonals will create isosceles triangles. Alright? So that's very useful when you're trying to figure out angle measures, side measures, is that those rectangle diagonals will create an isosceles triangle. 2 on top, 2 on the sides. Top and bottom, 2 on the sides. Now, all the properties of rhombuses and all the properties of rectangles are contained in squares. So squares are special because they have all properties of rhombus and rectangle. It's both simultaneously a rhombus and a rectangle. So all of its sides are congruent, all of its sides are perpendicular. Its diagonals are perpendicular, and its diagonals are congruent. Its diagonals bisect the angles, and its diagonals create isosceles triangles. All those things are true for squares. So let's just roll down here a little bit and talk about trapezoids. All right? What's special about a trapezoid is that it has one set of parallel sides. Only one set. And the same side interior angles between the parallel sides are supplementary. Right? So that's not true for all quadrilaterals, but it is true for a trapezoid, and that comes from the set of sides being parallel. Because the sides are parallel, then the same side interiors will be supplementary. Just wanted to point that out. So the isosceles trapezoids, what's special about that is that the non-parallel sides are congruent, which means the base angles are congruent. All right, so again, we saw that with the diagrams. If any of this seems a little strange to you or you don't quite understand, go back and compare what I'm saying in the writing with what was marked on the diagrams. Right? These are the same information, just kind of presented in a slightly different way. All right? So what are some properties of kites that make them different from other quadrilaterals? Well, first of all, we're going to point out that there are no parallel sides. Now that's not different than most quadrilaterals, but it is different than the parallelograms, it is different than trapezoids. So we'll point that out. There are no parallel sides. There are 2 sets of congruent sides. And the diagonals are perpendicular. All right? So those are the things that you need to be aware of for kites. There is also one line of symmetry, which is important when you see that one diagonal that cuts that kite in half. That can give you a lot of information about everything else, and it does create right triangles, so you could use those properties of right triangles to figure out a lot of information about it. So I've got one more thing to show you and talk about, and this is kind of like a flow chart that kind of represents a progression, right? Quadrilaterals are the most basic of the 4-sided figures, right? To be a quadrilateral, very basic. All you need to do is have 4 sides, and your interior angles need to add up to 180 degrees. If you can qualify for those 2 characteristics, you're a quadrilateral. And then we're going to look at this from an inclusive standpoint, meaning As long as you have these certain properties, then you qualify as this type of shape. So, trapezoids. Trapezoids have at least one set of parallel sides. Parallelograms have two sets of parallel sides. A rectangle will have every property of a trapezoid. Any properties that I told you about trapezoids are true for rectangles as well. There's nothing that a trapezoid, including isosceles trapezoids and right trapezoids, there's no property that any trapezoid has that a rectangle does not also have. So in a sense, you could call a rectangle a trapezoid. There are no properties of parallelograms that a rectangle does not have, so you can call a rectangle a type of parallelogram, right? So a rectangle combines the properties of trapezoids and parallelograms together to become a rectangle. The same thing as a rhombus combines the properties of parallelograms and kites together to form a rhombus, right? All the properties of kites. The diagonals are perpendicular. Consecutive sides are congruent. All of those properties are true for a rhombus. Parallelograms. All the properties of parallelograms are true for a rhombus. So you could kind of say that a rhombus is a combination of a kite and a parallelogram together, all right? And of course, squares up here on the top, they're the most special of all. They combine all the properties of rectangles, rhombuses, trapezoids, parallelograms, kites, quadrilaterals, all that stuff comes together to make a square. So if you want to be at the top, you have to have the most properties, right? You have to be able to really prove that you belong on the top. To progress from the bottom of this flowchart to the top, every step needs to have more information. In order to get from one level to the next, you need to have additional pieces of information. Without that additional information, you can't progress up to the top, right? So kind of look at it like that, a flowchart, and remember that anything that's in a higher level has all the properties of the lower levels that flow into it, right? So a rectangle does not have the properties of a kite. There's no arrow going from kite to rectangle, right? There's no, rhombuses don't have the properties of trapezoids, but they do flow. From every arrow, whichever it goes, if it's connected, it has the property of anything below it. All right, so I hope that helps explain. There's just another way of looking at it. So try to kind of wrap your mind around how these relate to each other, because it'll help you when you're trying to distinguish between what shape is what. All right, we'll talk about this and practice it more in class next time.